Hi everybody, welcome to today's video. We're going to be looking at indices. First of all, this is where it comes from, the syllabus. We're going to extend and apply the index laws to variables using positive integer indices. I'm not actually going to cover the 0 one today. These are the revision questions that you should do in your workbook. So you can pause the video now and do that. List the first 5 prime numbers. A prime number has exactly 2 factors. So the first number is 2. First prime is 2, then 3, 5, 7, and 11. 1 is not a prime number. It has 1 factor. When we write 12 as a product of prime numbers, so product means times, prime numbers are numbers like 2, 3, 5, 7, 11. We get 2 times 2 times 3. 2 2s are 4, and 4 3s are 12. Write this number in index form. So by that we mean the 3 squared times 5. So we've got 2 3's here. 3 times 3 is 3 squared. Write 20 as a product of prime numbers in index form. So we're combining all the things from question 1, 2, and 3. 20 is 2 times 2 times 5, which is 2 squared times 5. The new examples for today's work, if we have 3 squared times 3 to the power of 4, we can add the indices, so the green parts. So 2 and 4 get added together. So 2 and 4 is 6. When we have 3 to the power of 6, 3 is called the base, and 6 is called the index. So this is why it works. So when we work in expanded notation, this is why it works. 3 squared means 3 times 3. 3 to the power of 4 means 3 times 3 times 3 times 3. So all of this combined is 3 to the power of 6. For example B, if we have x as our base, the same rules apply. So we've got 2 and 4 for our indices, so we add them together. So we get x to the power of 6. And it's the same thing, why it works. X squared means x times x. X to the power of 4 means x times x times x times x. So we get x to the power of 6. In example 1c, we introduce coefficients, so the blue numbers. So the blue part is called the coefficient of x cubed. In this example, the coefficient of x squared is 4. So I like to do the blue parts first. So 5 times 4 is 20. And then we do the indice parts. So we add the indices here, add the top numbers. 3 and 2 is 5, so we get 20 x5. This means 20 times x5, but when we simplify it, we don't add in the times. We don't include the times. All right, now would be a great time to do some questions. So from the textbook or online. The next examples involve division. Example 2. So it's a different rule to what we had before for timesing. This rule, we subtract the indices. So 4 take away 2 is 2. Why this works, if we have 3 to the power of 4, that means 3 times 3 times 3 times 3 divided by 3 times 3. Effectively, we can divide this 3 by 3, which is 1. Divide this 3 by 3. So effectively they cancel out and we're just left with this part. 3 squared. Next example. So if we have x to the power of 4 divided by x to the power of 2, when we divide, the rule is that we take away. So 4 take away 2, so we get x squared. How it works, x to the power of 4, we've got 4 x's, so x times x times x times x, divided by x squared. This cancels out. So we just end up with x squared as our answer. For part C, if we include the coefficients, so in this part, the green ones, we add the step of going 6 divided by 3, which is 2. So we do the green part first, 6 divided by 3. Then we do the x part. So we've got 5 minus 3, which equals, so 6 divided by 3 is 2. And when we subtract 3 from 5, we get x squared. So our final answer is 2x squared. Example D is similar to this one, but instead of using a division sign, we have fraction, so the vinculum here. And we simplify the fraction. So 8 over 10 gets simplified. So divide both by 2. So 8 over 10. We can do the x's separately. So this works the same way as here, the 5 take away 3. It goes 7 take away 3. So we get 4x. So we get 4 over 5, which is a simplified fraction here. We're dividing by 2. Dividing by 2. To get 4 over 5 and x4. Okay, you definitely need to practice these concepts.